Welcome to my class. I'm Drew Collop. In today's class, we're going to look at factoring. This is the first lecture in a series of lectures where we will discuss factoring. We have discussed factoring in previous lectures, but we're going to formalize it here. When we did prime factorization, we factored our numbers. When we were trying to simplify fractions, we factored our numbers. Let's look at factoring in more detail now. What are factors? Factors are numbers or variables when multiplied together produce a given number. Factoring is the process of finding the factors and taking them out. You can think of factoring as the opposite of distribution. In distribution, we have a number outside the brackets. We must distribute that number to all numbers inside the brackets. This is the opposite. If we have a common value between all of our terms, we can take it out, place brackets on the terms that remain, and place that factor outside the brackets. Let's look at some examples here. What are factors of the following values? I want you to try this right now. Try and take out all the factors of these numbers. Factors would be whole numbers or variables. Try that now. Let's take it up. After doing much prime factorization, you should be pretty good at this now. 3 is a prime number, meaning only 1 and 3 can be multiplied together to give you 3. 6 is not a prime number. 1 and 6, but also 2 and 3. So 1, 2, 3, and 6. 1 times 6, 2 times 3. 1, 2, 3, and 6 are all factors that can be taken out of 6. What about 6x? Well, here we have 1, 2, 3, and 6, but we also have x. Yes, variables can also be factors. Like x, y, and z, we have 3 factors, x, y, and z. Finally, 6xy, we have 1, 2, 3, 6, x, y, and z. Now that we know how to break down numbers into factors, let's review prime factors. Again, we have done this earlier with prime factorization. So try this now. Break down these numbers into prime numbers, just like we did with prime factorization. So you can break the number down, but make sure all the numbers in the end are prime numbers. Try that now. What do we get with 10? 10, 2 times 5. So those are our prime numbers there. 9, we get 3 times 3. 20, we get 4 times 5. However, we're not done yet. 4 is not a prime number. So we have to break that down into 2 times 2 times 5. Lastly, we have 40. We can break that down into 4 times 10. But both 4 and 10 are not prime numbers. So I need to break down the 4 into 2 times 2. I need to break down the 10 into 2 times 5. Now we have 40 broken down into its prime numbers. Again, we did this with prime factorization. Hopefully you learned it then. Many times when students are learning something, they already know an easier way to do it from a previous course, and they fail to learn the new concepts because they don't feel it's necessary. Everything in this course, I try and make it so you will use it. Once again, please learn everything I teach you in this course. If you don't immediately see the reason why you're doing it, perhaps there's a technique later on that you don't understand yet, that I'm going to use that basic concept to build off of. At this point, this has all been review. We've done all of this when we did fractions and prime factorization. Now let's look at factoring polynomials. So when we factor a polynomial, we express it as a product of 2 or more polynomials. You can think of it as the reverse process of expanding. Oftentimes we need to do this to solve for an unknown. Later on we'll use this to find the zeros or the x-intercepts of an equation, but there are many different types of ways to factor. Today we're going to talk about only 2 of them. The first one is called common factoring. You always need to try this first. Let me repeat that. When trying to factor a polynomial, always try and pull out a common factor first. It's the easiest way to factor. Sometimes you look at an expression and it looks far too difficult to factor. But if you pull out a common factor, it makes it much easier. You will see that as we work through this lecture. So here we have AB plus AC. Let's pull out a common factor. Well, what's common between these two terms? A is common. It is a common factor. So I can pull that out and put brackets around what remains. You can see it is the opposite of distribution. You can always double check by doing distribution on your answer. We distribute the A, we get AB plus AC. Checks out. This technique is not very difficult, and it is the first technique you should try when factoring. Let's try some examples now. We have A squared plus AB. What's my common factor between this term and this term? It's an A, but only one A. I have two A's here and only one A there. So I can only pull out a single A. Gives me A plus B inside the brackets. Let's now look at B. What is our common factor between these values? Well, I see a 4 here and a 16 here. 4 is a common factor. But remember, when we're factoring, we're not just factoring numbers, we're also factoring variables. Here we have 2Ks, and here we have 1K. So here I can pull out a 4 and a single K. This leaves me with K plus 4. If I was to distribute this back in, 4K times K is 4K squared. 4K times 4 is going to be 16K. What about the next one? Common factor of 3, but there's no common variable there. 3 comes out. D is a bit of a tricky one. There's no common variable, there's no common number. But actually there is a common number. Note, you can always factor out a 1 every time. Oftentimes when you're working with equations, you may have to make that first term a positive value. So what I can do is I can factor out a -1 from both of these. It basically switches the sign. I pull a -1 out, and I get B minus 4, which I could make that as negative B minus 4. You'll see this later on in some of our calculations, where you'll have to turn that negative B into a positive B. What about the next one? 25m cubed minus 15m squared. So I can pull a 5 out of this one. And here, I have m cubed and m squared. I can pull only an m squared out of both of them. Why? Because this one is only squared, not cubed. So I can pull a 5m squared out. I take 5 away from 25. I get 5 remaining. I take m squared away from m cubed. I have a single m remaining. Subtraction symbol there. 15 divided by 5. I have 3 remaining. And that's it. What about f now? I have x squared. I have an x, so I have a common factor there. But I don't have an x here, so that's not going to work. I have a y here and a y here, but no y here. So that's not going to work either. But you should always try common factoring first. Always try common factoring first. I put this here as an example, is that sometimes it will not work. Don't worry. There's more to come. There's a large number of practice problems here. A through G. Give these a try now, and we'll take some of them up. Let's take up the first one. We have 9a cubed plus 27x squared. We look at our numbers. I can pull a common factor of 9 out. Look at my variables. I have no common factor there. So I can only pull out a 9. When I do that, I have a cubed remaining. If I divide 27 by 9, I have 3 remaining, x squared. What about the next one? Look at the numbers. I can pull a 3 as a common factor out of all of them. Can also look at the variables. I can pull just a single x out. Why just a single x? Because that's x cubed, and that's x to the 5. So I can only go with the lowest degree term. X to the 1 is the lowest degree. So when I solve this, I get 3x comes out, leaving me with x to the 4 minus 2x squared plus 3. For the remainder of these problems, I don't think these are very difficult. If you scroll down to the bottom, you can see here's the answers for practice 1 right here. So double check your answers with the answers on the page here. If you have any problems with that, email me outside of class or ask me during tutorial. Now let's examine the next way to factor, difference of squares. What does the term difference mean? It means subtraction. So this is when we're subtracting two squares. Let me show you where this comes from. Here we have a minus b times a plus b. So let's distribute first of all. Here and here. This gives me a squared plus ab. Then we'll distribute the negative b to the other values. This gives me minus ab minus b squared. Notice what happens. I have plus ab minus ab. So these cancel each other out. This then leaves me with a squared minus b squared. This is the difference of squares. So it's a difference of two squares. What happens is, if you see you have two squares and they're subtracted, what we do is we break them up. So I take the square root of this one and the square root of this one, and I place them here. I then place a positive sign between the two terms and a negative sign between the other terms. It also doesn't matter the order. We could say a minus b times a plus b. Remember, when we're multiplying, it doesn't matter the order. Please note, this does not work for a sum of two squares. This doesn't work. So make sure you don't confuse yourself with that. So as you can see, when we distributed, we got that. This is just the reverse of distribution. Let me show you how this works. Example 4a. Factor the following expressions. We see this is two squares. I can take the square root of that and the square root of that. In addition, it's a difference of two squares. So I can make this as y plus 2 times y minus 2. Done. So once again, we took the square root of those numbers, we put a positive sign between two terms and a negative sign between the same terms, but in a different set of brackets. Let's try the next one. I know 25. I can do the square root of that. That's 5. 4x squared. Square root of 4 is 2. Square root of x squared is x. This gives me 2x plus 5 times 2x minus 5. See now. Square root of 16x squared is 4x. Square root of 9 is 3. 4x plus 3 times 4x minus 3. Once again, remember, it doesn't matter the order. I could have written it like this as well. It means exactly the same thing. What about D now? D looks like it might be a problem, right? I have negative 81 plus y to the 4. Let's just rearrange it. Let's put y at the start, and we'll put the number at the end. We have the difference of two squares. Square root of y to the 4 is going to be y squared. Square root of 81 is going to be 9. Difference of two squares. Let me remind you, if I have y to the 4 and I take the square root of that, let's turn that into a fractional equation. Square root, this represents a fraction of 1/2 as the exponent. So this is y to the 4 over 2, which gives me 4 divided by 2 is 2. So that's how you would take the square root of y to the 4. Let's now work this out. Y squared plus 9 times y squared minus 9. Now, oftentimes, you'll see in these problems it says factor completely. Is this the final answer? Ask yourself, can we keep going? We can. Notice, this here is still a difference of squares. This is a sum of squares, so we can't do anything with that. But this one we can break down even further. Let's do that now. So I transfer this down to the next line, y squared plus 9. And this one, if I take the square root of y squared, it's going to be y. Square root of 9 is 3. This gives me y plus 3 times y minus 3. Final answer now. So be careful with that. If you get a problem that asks you to factor completely, make sure you double check at the end. Can I pull additional factors out, either common factors or using a difference of squares? Again, a large number of practice problems here. We have A through to G. Give those a try now. Let's take some of them up. Let me remind you that at the end of your notes, here's all the answers to those practice questions. So if you want to double check your answers with these answers, please do so. I'll take up a few of them. Any of them I don't take up that you still have problems with, please talk to me outside of class or ask me during tutorial. Let's take up B, 25a squared minus 36. Square root of 25 is 5. Square root of a squared is a. Square root of 36 is 6. This will then be equal to 5a plus 6 times 5a minus 6. What about C? C looks like a challenging one. How would we do that? Well, we can see here, this is a difference. We have subtraction here. We have the square root of this. Square root of 16t to the 4 is going to be 4t squared. What about the 1? What do we do with that? What's the square root of 1? Just 1. Be careful of that. This gives me 1 plus 4t squared times 1 minus 4t squared. See how that works? What else do you notice about this particular question? I can keep going right here. I copied this down. This is the sum of two squares. I can't apply my law to that, but this is a difference of two squares. 1 plus 2t, 1 minus 2t. So once again, if it says factor completely, make sure you do that. See if you can continue to factor after you do your first step. D and E are pretty simple. Let's look at F. So here I have a difference. There's a problem with this though. What's the square root of 2? What's the square root of 32? These are not whole numbers. What do we do here? You should know the answer to this if you've been listening to this lecture carefully. What do we do first? What do we always try and do first? We always try and pull a common factor out first. What's a common factor between 2x squared and minus 32? Common factor is 2. Take that out. X squared minus 16. See what we get now? Now we have the difference of two squares. Square root of this, square root of that. This gives me 2 times x plus 4, x minus 4. Final answer. So remember, if it doesn't look simple to start with, you probably have to take a common factor out first. Try and remember this when you're doing factoring all the time. Always look for a common factor first. We had the exact same issue with G. Let's first rearrange it. We'll move the 300 to the start. We'll move the 3b squared to the end. These two things are equal to each other, right? This is positive 300 minus 3b squared. Same thing. Just make sure you keep the negative sign with the 3b squared. Now, this is not a difference of squares until we pull out a common factor. Common factor between the two, I can pull out a 3. 100 minus b squared. Now we have a difference of squares. Square root of 100 is 10. Square root of b squared is b. This will then give me 3 stays on the outside. Don't get rid of that. This is a common mistake students do. They pull the common factor out and then they just let it disappear. No, it's part of the expression. You can't remove it. So the 3 remains. We have 10 plus b, 10 minus b. Final answer. Again, make sure you don't remove any numbers. I see that all the time. I don't know why students pull the common factor out and then they just get rid of it. You can't do that. It changes the value of that expression. Leave it in there. So in today's lecture, we started looking at factoring. We examined pulling out a common factor, looking at a common number or common variable that is in all terms. If you have that, pull that out. Remember to always try and pull a common factor out first. It will make your job that much easier. If you forget, quite often you can still factor, but it makes your job infinitely more difficult. Also, we looked at a difference of squares. This is when we have 2 perfect squares and they're subtracted one from the other. In doing this, we can take the square root of both of those terms, and then we take the square root, put a positive sign between 2 of them and a negative sign between the other 2, and multiply those together. Remember, factoring is the opposite of distribution. You'll understand later on why we do this. That's all for today. Until next time.